Basics of control systems. We will see the problems related to block diagram reduction. The first one. Find the overall a single block for this. Solution. See, directly I can write my CS as nothing but RS plus RS into G2 plus RS into G1 G2. Okay, thus CS by RS can be written as 1 plus G2 plus G1 G2. See, why RS first? Because input is directly given at the output. RS G2, because the same input is gone here and from here it is multiplied by G2 and gone to the output. RS G1 G2, this one is RS G1 G2. Okay, so I'll get a single block, which is 1 plus G2 plus G1 G2 RS and CS. Okay, so this is the required block diagram for the question. Second problem. For the block diagram shown in figure, find the single block find the overall or a single block representing the full block diagram. Okay, so looking at the question, I have two takeoff points. One is from here and one is from here. Either I can take this takeoff point to this place or I can take this takeoff point to this place. Okay, we can do any of the thing. It's our choice. So let's try by taking this takeoff point to this place. So if I take this takeoff point from here to here, I will have block diagram something like this. I will redraw this. One by G3, G1, G2, G3, H2, and RS. Okay. Now it is much simpler. This is one block. This block is in cascade with this block. And overall is another block. Okay. So it can be simplified to 1 plus G2 G3 H2. This is my RS, this is my CS. This can be further simplified G1 G2 G3 1 plus G2 G3 H2. Okay. This can further be simplified to the last this thing G1 G2 G3 upon 1 plus G2 G3 H2 upon 1 plus H1 by G3 G1 G2 G3 over 1 plus G2 G3 H2. Okay, this will get cancelled. This will be G1 G2 G3 over 1 plus G2 G3 H2 plus G1 G2 H1. This is the final block representing the combination of all the blocks. If input is given is RS, output is CS. Okay. So this type of problems are expected in GATE exam. Okay. Now one more thing is, we are solving this problem by making use of only block reduction diagram. Okay. But if sometimes if it becomes a very complicated situation, then there is another way of solving this problem using signal flow graph. We will see that method in the upcoming topics. But now we will solve more problems related with the effect of feedback and reduction of block diagrams. Again a similar problem. G1 G2 G3 H1 when it is a direct line, that means the feedback factor in this is equal to 1. RS, here it is CS. Find RS by CS or make it as a simpler block diagram. Now, directly we need not to shift any breakaway point, we need not to move any summing point, or we need not to move away or ahead any takeoff point, or we need not to move any summing point also. This is one block. Directly I can write for this block as G3 upon 1 plus G3H1. Okay. Now we have to move this summing point from here to here. Okay. After moving this summing point from here to here, it will be some multiplication at this point. That will be reciprocal of this. Okay. Now it is quite simple. This is just one block, and this block and the top block are in parallel. These two blocks are in parallel. That means parallel blocks are added up. Okay. Solve this to get the answer. Okay. Simple question. But it will be much simpler if we use signal flow graph.